Astronomers just measured plasma crossing the sky at 20 times the speed of light. That's not a typo, that's the actual published finding, checked and rechecked before release. Stay with this, because the explanation is stranger and more satisfying than the headline alone. It involves a black hole, a beam of plasma, and a trick of light itself. Nothing in this universe can move faster than light. This is one of the oldest rules in physics. Einstein proved it over a century ago. In all that time, no experiment anywhere has ever broken it. So how do you explain a single measurement that appears to shatter that rule? In April 2017, radio dishes stretched across the planet locked onto one target. One dish sat in Hawaii, one sat high in Chile's desert, one sat buried at the South Pole. None of them alone could resolve what happened next in the sky. Combined, all three became something else entirely, a single instrument spanning the whole planet. For one full week, they all stared together at one point of light in Virgo. That point was Quasar 3C279, a galaxy powered by a monster at its core. It was already well known among radio astronomers. Long before this particular discovery, it was first cataloged as a radio source decades before anyone knew what powered it. It sits roughly 5 billion light-years from Earth, near the constellation Virgo. A supermassive black hole, roughly 1 billion times heavier than the Sun, powers it all. Numbers like that resist easy comparison. Hold on to this instead. 1 billion suns crushed down into a single point smaller than our solar system. Inside that week's data, astronomer Jae-young Kim found something that shouldn't be visible at all. A blob of plasma, shifting position frame by frame, racing near the edge of oblivion. Whatever this blob was doing, it was happening at an unimaginable scale. At face value, the raw math said something completely impossible. That blob was crossing the sky at 20 times light speed. 20 times, not 2, not 5. 20 full times faster than the one single speed nothing should ever beat. Here's the assumption most people naturally carry into a story like this. If something looks faster than light, the instruments must be broken, or the measurement is a fluke, or Einstein's framework has a hole in it. None of that is true here. Every one of those explanations sounds reasonable. Every single one of them turns out to be wrong. Keep that specific assumption in mind. You're about to watch every piece of that assumption fall apart. Quasar 3C279 sits at the heart of a distant galaxy. Its light left home before Earth's continents even looked the way they do now. 5 billion years is longer than planet Earth itself has existed. 1 billion solar mass black hole anchors the center. It's a gravitational drain, compressing matter toward a single point. Gas and dust spiral inward toward that black hole, heating violently the entire way down. That glow alone can outshine every single star in the surrounding galaxy. Not everything spiraling toward the black hole actually manages to fall in, though. Some material gets seized by twisted magnetic fields before it crosses that point. Physicists still debate the exact process that launches a jet, rather than allowing pure infall. Competing models exist among physicists studying this, and none has fully won the argument yet. The leading picture involves magnetic fields winding tighter in the disk until particles launch outward. Instead of vanishing forever, that material gets hurled back out as twin jets. Those jets don't drift outward slowly, the way smoke rises from a fire. They erupt violently, and all at once. Gravity and magnetism, working together, push that matter toward the cosmic speed limit itself. The resulting jet stays narrow and tightly focused across unimaginable distances. It barely spreads at all. Seeing a jet like that, from 5 billion light-years away, needs more than one telescope. It needs, in practice, an instrument roughly the size of a whole planet. Radio astronomers wrestled with this exact problem for decades before this particular technology existed. That's exactly what very long baseline interferometry provides for astronomers studying distant jets. The technique effectively turns the whole planet into the lens of one giant telescope. It links radio dishes scattered worldwide, timing their signals down to fractions of a second. Together they merge into one virtual instrument, roughly the size of Earth itself. The Atacama Array sits in Chile. The James Clerk Maxwell Telescope sits in Hawaii. The South Pole Telescope sits exactly where its name suggests, on the ice itself. All of them locked together, functioning as one enormous eye. Using this method, the collaboration resolved features inside the jet finer than 1 light-year. No optical telescope built anywhere on Earth gets close to that resolving power. Picture spotting a single orange resting on the moon's surface. Viewed from right here, That's roughly the level of precision this global network achieved. No single radio dish on the planet could ever achieve that resolution alone. Only the combined network spanning 3 whole continents made this possible. None of this happened by accident. None of it happened quickly. With that hard-won resolution finally in hand, Kim's team analyzed the April 2017 data. They published their full findings that same April in the journal Astronomy and Astrophysics. Their conclusion was plain once the long analysis finished. The jet material's true speed exceeded 99.5% of light speed. Real, physical, extreme by any measure of speed humans have ever recorded. Nothing traveling through our solar system moves anywhere close to that speed. Even our fastest human-made spacecraft crawl by comparison. And still, seen from Earth, it appeared to outrun light by a factor of 20. 2 numbers both true, sitting side by side in the same paper. So which is it? Is the object breaking physics? Or are we misreading the sky itself? Neither one is correct on its own. Both readings miss the actual answer entirely. The object's true, physical speed through space never crosses the light barrier. Not once. Not for an instant. That 20 times figure is real data. It sits inside a peer-reviewed paper, not some rumor floating online. It was measured carefully and eventually published, but it was never a real velocity. It's an optical effect built from geometry and the plane delay of crossing space. Once you actually see the mechanism at work, the entire paradox disappears completely. This wasn't even the first time astronomers had caught this exact illusion. Rewind to 1966. Physicist Martin Rees worked from pure theory alone, no telescope, no observation to lean on. He worked through the equations for an object near light speed, aimed at an observer. Under the right conditions, that object could appear to outrun light itself, not by breaking any law, but by exploiting a trick hidden inside relativity. At the time, it was just an idea sitting quietly on paper, waiting for proof. Rees had no way of knowing a distant quasar would soon confirm it for him. No observed example existed anywhere in the sky yet, not until real telescopes caught one. That confirmation came within just a few remarkable years. Between 1968 and 1970, an American-Australian team built an early trans-Pacific radio setup. One radio dish sat in California, the other sat in Australia. They aimed both dishes at the same quasar and tracked its structure over time. That quasar was 3C279 itself. The very same object re-examined decades later by the Event Horizon Telescope. They measured a component expanding by roughly 1 milliarsecond, a nearly invisible shift. Translated directly into velocity, that implied a speed of at least twice light speed. Historians Pearson and Zensis later called this the first interferometric measurement of superluminal expansion. A theory built entirely from equations had just met its first real, observed proof. That's a remarkably fast turnaround for an idea this strange. Knowing an effect happens is one thing. Feeling why it happens is something else entirely. Try this comparison. Picture an ambulance speeding almost straight toward you, siren blasting the entire way. As it closes in, each pulse has less ground left to cover than the last. The pulses arrive bunched together, more compressed than when emitted. That shift is the ordinary Doppler effect, the exact one you've heard on any street. It's why the siren sounds higher in pitch, then drops the instant it passes. Now take that same idea and swap the sound for light. Imagine that same ambulance somehow moving at 99.5% of light speed. Each headlight flash would arrive almost right behind the one before it. The ambulance has nearly caught up to its own earlier light by the next flash. Now calculate that ambulance's sideways speed the ordinary way, using distance divided by time. You'd end up with a number far beyond its true, actual speed. Not because it broke physics, but because you were reading a compressed clock. That single compressed clock is the entire secret hiding inside 3C279's jet. Nothing about the underlying physics here is genuinely exotic or new. It's the same ordinary geometry, just pushed to an extreme nobody encounters on Earth. Picture that same idea, applied now to jet material racing toward Earth near light speed. Every burst of light it emits travels a set distance to reach us, but the source keeps closing that distance the whole time. By the next burst, the source has already covered part of that gap. Each pulse, as a result, has slightly less ground to cover than the last. That tiny difference, repeated across countless bursts, changes everything an observer ends up seeing. The bursts, because of this, don't arrive spaced out the way they were emitted. They arrive bunched together, squeezed into a far narrower window than the true interval. Instead, they're seeing a clock artificially compressed by light travel time itself. Now do the math the way any observer naturally would, unaware of the hidden squeeze. Apparent speed simply equals distance moved divided by the time you measured. Simple enough. But that time measurement, the bottom half of the equation, has been artificially shrunk. Shrink the bottom number enough, and the result inflates past light speed. The object itself never once exceeded that limit, regardless of what the naive calculation suggests. This entire inflation effect has a very specific sweet spot, it turns out. It peaks under two conditions at once. The true speed must sit extremely close to light speed, aimed almost at the observer. Tilt that precise angle even slightly, and the illusion collapses back towards something ordinary. That's precisely why this apparent motion isn't seen in every jet across the sky. It isn't rare because the physics is exotic. It's rare because it demands one very specific, narrow viewing geometry. Out of countless jets scattered across the sky, only a rare few ever satisfy it. Out of countless jets across the universe, 3 C279 happen to satisfy it almost perfectly. Kim's 2020 measurement pinned the jet's true speed above 99.5% of light speed. That same jet also happens to point almost directly at Earth. Combine near light speed with near perfect alignment, and you get the apparent 20 times figure. A very Broderick of the Perimeter Institute named this precise resolution directly, without hesitation. Dom Pesci of the Center for Astrophysics summed the whole idea up in one line. The material is racing toward us, chasing its own light. Remember that assumption from the start, the one that said the measurement must be broken. It wasn't broken at all, it was simply missing its other half. One object studied once could still be dismissed as a fluke. So researchers went looking for independent confirmation elsewhere in the universe. Different telescopes, different targets, entirely different teams working decades apart. In 1993, a team led by Thomson and colleagues studied a different quasar, 3C273. Using the same VLBI technique, but their own campaign, they tracked its inner jet. The result, an apparent speed of up to 9.6 times light speed. A different quasar studied entirely on its own, a different research team altogether, a different measurement history from start to finish. Yet it's the same underlying illusion, produced by the exact same geometry. Then in 1994, confirmation arrived at a completely different physical scale. Astronomers discovered an object called GRS 1915+105, sitting inside our own Milky Way. This time it wasn't a supermassive black hole at all, but a microquasar instead. A stellar mass black hole, just a few times heavier than the Sun. It shows the exact same jet behavior, just on a much smaller stage. Separate plasma blobs in its jet expanded by 0.5 arcseconds within a few weeks. Billions of light-years shrank down to only a few dozen light-years. Decades shrank down to mere weeks. The scale of the entire show changed dramatically. The mechanism underneath all of it never changed at all. Whether the black hole weighs a billion suns or a handful, the geometry doesn't change. One final thread ties back to this same idea, long before anyone understood relativity. Back in 1901, astronomer Charles Dillon Perrine photographed the exploding star Nova Persei. What he saw through his telescope looked like a cloud expanding at an impossible rate. No black hole was involved here, no relativistic jet, no plasma near light speed. What he'd actually captured was a light echo. Light from that nova's outburst reflected off surrounding dust, faking motion where none existed. The cause here was entirely different from anything happening at 3C279. The warning runs through this entire story, though, from start to finish. Appearances built from light rather than direct measurement can lie about speed. Deep inside the jet, the Event Horizon Telescope collaboration also found a twisted structure. That's a far cry from the simple straight beam most jets are pictured as. Jae-Young Kim compared it to opening the smallest doll inside a nesting doll set. Inside was a completely different shape. That twisted geometry suggests the jet isn't one smooth outward flow. It likely contains traveling shocks, folded into a bent and rotating structure. That twisted structure may explain why this jet also flickers with unpredictable gamma-ray flares. It brightens within just a few hours, in ways a straight jet never should. Step back now and look at the full shape of this entire story. Every thread gathered here points to the exact same resolution, a theoretical prediction on paper in 1966, direct confirmation on this exact object by 1970, a precise measurement of the true speed in 2020, Independent proof from a different quasar in 1993. Independent proof from a different scale of black hole in 1994. An older, unrelated warning about the tricks light can play, dating back to 1901. What looked like a crack in Einstein's speed limit turns out to be its opposite. It's one of relativity's most elegant confirmations, quietly hiding inside a quasar's jet. The 20 times measurement was never a flaw in physics at all. It's exactly what physics predicts for material near light speed, aimed nearly straight at us. Our ordinary intuition about distance, time, and speed works fine for ambulances and streets. It works for almost anything we can touch, hear, or watch pass by. That same intuition quietly breaks down once something nears light speed pointed directly at you. Right now, at this exact moment, that same blob of plasma is still out there. It is still tearing through that same jet at over 99.5% of light speed, aimed almost at Earth. It is still chasing the very same light it just emitted a moment ago, forever closing the gap, forever failing to catch it.